What's up, 8th grade? Mr. Agnos here. This video is for homework 15-4. And this week, we're going to be talking about relative frequency tables. And the difference between a relative frequency table and an ordinary frequency table, like we looked at last week, is that a frequency table, and here's an example right here I'm going to highlight. This is a frequency table like you saw last week. This one has the actual numbers. Right, the actual numbers, whereas a relative frequency table uses percentages. Okay, it says what percent of the whole does each number represent. So that's the big difference. So what we have to do is we have to take the information that's in the frequency table, convert them to percentages, and then once they're in percentages, we fill out the relative frequency table. So instead of the actual numbers, we're looking at percents. So let's give it a shot. A stockbroker compiled data about 50 popular stocks. That's our total. You can see that number right here. She made this frequency table to show how their changes in 2010 compared to their changes in 2009. So when they say changes, what they mean is they use these words positive change and negative change. A positive change means it went up, you made money, and you're happy. A negative change means it went down and you lost money and you're sad. Okay? So maybe a stock went up in 2009, but it went down in 2010, and what percent of stocks fit into that category. Okay, so what we're going to do is we're going to take each of these entries in our frequency table and convert them into a percent for our relative frequency table. And the way you do that is you take, let's just pick a category here. I'm going to start in the upper left. So I want to know about this box right here. Stocks that went up both years, positive change in 2009 and a positive change in 2010. And there were 11 stocks that did that. So what percent of the total is that? Well, the way you solve that is you take 11, you divide it by the total number of stocks, and you multiply by 100. It's going to be the same process for every single number on this assignment. Take the number, divide it by the total, multiply by 100. Now, the total is actually going to change. More on that in a second. All right, so this is step 1. All right, for step 2, you're going to get a decimal. All right, so 11 divided by 50 is what? 11 divided by 50 is 0.22. Okay, and then if I multiply this by 100, anytime you multiply a number by 100, you just need to move the decimal point 2 to the right. There's 1, there's 2. So my answer is 22%. So 22% of the stocks had a positive change in 2009 and 2010. They went up both years. So that'd be 22. Okay, I'm going to do one more. I don't have time to fill out the entire table, but I want to make sure that you know how to what to do with these total columns. So let's look at stocks that had a negative change in 2009. So they went down in 2009, but they went up in 2010, right? So we're looking at this box right here, and that number was 14. So what percent of the total is 14? So just like before, we'll take 14. That's the number of stocks that went down in 2009, but up in 2010. We'll divide it by the total number of stocks. We'll multiply by 100. So 0.14 divided by 50 is 0.28. And if I multiply that by 100, I get 28%. So I go here, I put 28. And then for the row total, for this box right here, I just add these two up. 22 plus 28 is 50. And what that means is 50%, so this row is complete. So 50% of the stocks had a positive change in 2010, right? So we know that in 2010, half the stocks went up. Okay, and then you're just gonna do the rest of the table, right? You're gonna find these two numbers, right? You're gonna add them up. Now everything should add up nicely, right? This should add up to 100 right here, and then these two totals should add up to 100 right there. Okay, let's take a look at a different type of problem. All right, number 3 is a different type of problem. It says, in a recent survey, 40 people were asked, do you like thunderstorms? 40 people is the total. There's the number right there. The frequency table shows the results of the survey. There's our frequency table. So these are the actual numbers. Complete a relative frequency table. That's this one right here, right? That's going to use percents to show the distribution of the data with respect to gender. That's the difference now. I'm not comparing the numbers to the total. I'm comparing the numbers to the gender. So let me show you what that means. All right, let's start here in the upper left. So I want to know the percent of men that liked thunderstorms. So I'm not interested. So this number right here, I'm not interested in comparing this to the total number of people. I'm only interested in saying, well, what percent of men does this represent? So I have to look at this number right here for the total. That's where the with respect to gender comes in. So again, to say this one more time, I want to know what percent of men, not what percent of the total, because this number doesn't represent what percent of the total, right? Because there's women that like thunderstorms too. So what percent of men like thunderstorms? So I would take the number of men that like thunderstorms, 13, divide it by the total number of men, multiply by 100, and I'll have my percent. All right, the next thing is you also have to round to the nearest tenth as needed, right? So 13 divided by 22 times 100 equals. So if I do all this math, I get 59.0909, and those 09s, they repeat. All right, I have to round this to the nearest tenth. So the 10th spot is the first decimal. And so I look to the right and I say, is this number greater than 5 or greater, or is it less than 5? Well, it's clearly greater than 5, so that means this becomes a 1. So 59.1% of the men in the survey like thunderstorms. Okay. What about, let's look at the men who didn't like thunderstorms, right? So there's more than one way to do this. You can do some subtraction here. So if 59.1% do like them, then just subtract that from 100, right? And that will tell you how many do not like them. So I believe that's, I believe that's going to be 40.9. Right. All right. Let's look at the women here. So what percent of women like thunderstorms? Well, there were 10 that like thunderstorms out of a total of 18 women. So I would do 10 divided by 18 times 100. And I get 55.5 repeating. So these 5s go on forever. It says to round to the nearest tenth. So here's the tenth. This is 5 or greater, so this is going to become 55.6%. Okay, so what's important to understand about this type of table is that it's only going to add to 100 going this direction, which is why they have all the hundreds there. It's not going to add to 100 going this direction. All right, it's only going to add to 100 in the row direction. So when I get to the last column here, or I'm sorry, the last row, and it says I have this totals here. So we just say, okay, 23 yeses, right? That's kind of regardless of gender, out of the total of 40, right? Because we're thinking in this direction. So I would do 23, that's a 22. I would do 23 divided by 40 times 100. $57.5. So that's 57.5%. So that's the one that number tells us, regardless of gender, 57.5% like thunderstorms, right? And then to fill out these remaining two boxes, you could calculate you could use the actual numbers over here, or you could just do the subtraction to figure out those remaining. Okay, there's one more type of question where, so this frequency table is called a row relative because we move in this direction. Well, we also have what are called column relatives, where we move down the columns. So let's take a look at number 6. Okay, a teacher asks 130 students. That's our total. All right, you can see that number right here. How much time do you usually spend online each night? The frequency table, that's right here, shows the results. These are the actual numbers. Complete a relative frequency table to show the distribution of the data with respect to grade. So not the total. We want to know with respect to grade. And notice that it says column relative right here. So we're going to be moving in this direction. So everything in our columns should add to 100%. So let's just start with this box right here. All right, it says there were 10 7th graders who spend 0 to 15 minutes online each night. Yeah, right. Okay, so 10 represents what percent of the total number of 7th graders? Because remember, it says with respect to grade, not with respect to the total. So I need 10 divided by 52 times 100. And that's going to give me this number right here. And I'll try and get through the 7th grade column. So 10 divided by 52 times 100 equals, and again, you have to round to the nearest tenth. So rounding to the nearest tenth, I got 19.2. So 19.2% spend 0 to 15 minutes. Okay, let's look at this one. 24 out of 52 said they spent 15 to 30 minutes. So 24 divided by 52 times 100 is approximately equal to what? 24 divided by 52 times 100, 46.2. So 46.2. And again, to get this last box, you could add these two together and subtract it from 100, or you can just calculate it. I'm just going to go ahead and calculate it. 18 7th graders said they spent 30 to 45 minutes out of a total of 52 7th graders. So that'd be 18 divided by 52 times 100. And that is approximately equal to 18 divided by 52 times 100, 34.6. So this is approximately 34.6%. And that would go right here. And again, those should add up to 100. Okay, so a relative frequency table looks at the numbers as percentages. And then you gotta think, am I looking at the numbers as a percentage of the whole or as a percentage of some group, right? 7th graders within the whole, right? 7th graders are a group of students within the whole group. All right, I'm sure you're gonna have lots of questions. I'm out of time. I'll see you in class.